Now let's perform some further analysis of the received signal. In this case, now we will show you three other tools that we can use to analyze the signal. We will see the constellation diagram, polar diagrams, and also the eye diagram. Generally, these tools, and there are many more others that we will see in the other labs, they give a lot of information about the condition of the signal that we have received. But for today, in today's case, since we just have AWGN channel, so we will show few features, and in the other labs we will see more. So let's start with the constellation diagram. To plot constellation diagram, we use the scatter plot function from the MATLAB, and the input is the signal that you want to plot. And in this case, we will do for both, for the TX signal, the clean one that we transmitted, and the one that we have received. So we plot both of them so that we can easily see the differences between them. So let me plot this. So this is the results. As you can see, the constellation diagrams show us the location of the symbols in the IQ plane. So this is what we transmitted, very clean. But the one that we received, we can see now the effect of the noise very clearly, and how the noise can cause, so now here, based on the power of the noise, the symbols from this constellation can jump to the region of the other constellation. So as the noise strength increases, at some point all of these symbols will merge up, and we will not be able to do the proper detection of them. And also, if we use a higher modulation order, for example, that means the separation between the constellation will be small. So in that case, also the effect of the noise will be more detrimental. So this is for the constellation tool. Now let's move to another tool, which is a polar diagram. Polar diagram shows the transition of the symbols from one symbol to another, how the transition is made. So, and to plot the polar diagram, we just use the plot function with the real part and imaginary part of the signal entered separately, as you can see here. So also we'll do for both cases, for the transmitter and for the received signal as well. So we plot this one. Continue. So this is what we are getting. Here we can see the transition from one symbol to another is very smooth, because all of the symbols are exactly at one point, at the ideal point of the constellation. But in this case, because of the noise, the transition is a little bit rough, and the roughness will increase based on the strength of the noise as well. So one important thing about this figure, maybe we might not be able to understand it now, but the transition gives us the idea of the dynamic range of our signal, which is important thing to know, because the dynamic range determines how the hardware components like power amplifier will affect our signal. So now let's move to the last one, which is the eye diagram. Also, the eye diagram is very useful tool. We use it to analyze different effects of the system, like noise, like as we have today, and also we can use this to see if the system has any timing offset or inter-symbol interference, as we will see in the other labs. So also this one, you can do it yourself, or you can use a direct MATLAB command, which is eye diagram, which takes the input of the signal that you want to plot, and also the oversampling rate. So here you can use only one, or you can change this number based on the number of symbols you want to see in the diagram. So I'll put this one as well, and we will see. So this is the eye diagram for rectangular filter. I mean, the shape will change based on the kind of filter that you are using. So for the rectangular filter, this is the eye diagram, and this open space here is what we refer to as an eye. And based on the impairments available in the system, this eye will have different characteristics. And for example, in this case, we have noise. You can see as the noise increases, the eye will start closing. Here it is wide open, but here it starts closing. So at some point when the strength of the noise become too much, it will be completely closed and it will not be able to make any correct detection at the receiver. So for today, this is enough. As I said, we will get to know more about these tools. There are so many things we can observe by using these tools, but that we will see in the other labs, lab 2 and lab 3 specifically. So after this, we are almost done. Now you have the signal. You have the received signal here that we generated. Now what you need to do is to take this signal and develop a basic receiver implementation to detect the symbols that we transmit, and also you will have to do the error rate analysis. In that case, you will have to put the bit error rate versus SNR. Remember, you will have to repeat the whole thing that we did for different SNR values. We only did for 10 dB. Now you have to repeat the same thing for 0, 3, and 5, and make the comments based on what you observe. Like if you change SNR, how different things change in your system, and you will have to answer the questions available in the manual based on your observation. And also you will be provided with another code similar to the one that we went through, but that one will have extra impairment, which is frequency offset. So the code will simulate the effect of frequency offset, so you will have to observe different effect of frequency offset on the signal. This also is straightforward, similar to the one that we have gone through, but with just some extra impairments. So you'll have to do this. The code will be given to you and you will implement it.